Find all real zeros of p of x equals x cubed plus 2x squared minus 13x plus 10. And then after that, we're going to write the polynomial in factored form. This is a polynomial with the leading coefficient 1 and the constant coefficient 10. The leading coefficient 1 has factors plus or minus 1. 1 times 1, or negative 1 times negative 1. The constant coefficient 10 has factor plus or minus 1, plus or minus 2. The factors are basically the divisor of the number, plus or minus 5, and then plus or minus itself. Any factor of the leading coefficient is called Q, and any factor of the constant coefficient is called P. The rational zero theorem says that the possible, not the zero, yes, but the possible zeros are the ratio of P over Q. This is the factor of the constant coefficient, any of these, over the factor of the leading coefficient. The possible zeros are therefore plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1, and these are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Any of these is the zero of the polynomial if, when we perform synthetic division, we end up with 0 in the remainder. And so, checking to see if x equals 1 is 0, we set up the synthetic division, 1, and then the coefficient of the polynomials are 1, 2, negative 13, 10. We start with the x cubed term, there's 1, and then the x squared terms, there are 2, and then there's the x term, negative 13x, and then the constant coefficient. Bring down 1. 1 times 1 is 1, 2 plus 1 is 3, 3 times 1 is 3, negative 13 plus 3 is negative 10, negative 10 times 1 is negative 10, 10 plus negative 10 is 0. So yes, x equals 1 is a 0 of the polynomial. We want to perform synthetic division because not only it tells us whether the remainder is 0 or not, but the last entry in synthetic division also gives us the other factor, which is the quotient. The number on the left-hand side of the remainder is the constant coefficient of the quotient. The number on the left of it is the coefficient of the x term, and the number on the left of it is the coefficient of x squared. What this means is that we can write p of x as x minus 1, which is x minus k. 1 is the number that we use in the synthetic division, times the quotient. The quotient is read off from the last entries in the synthetic division, and it is x squared plus 3x minus 10. Now, we're not done yet. We still have to go further by factoring x squared plus 3x minus 10. But at least we reduce it to a trinomial, so perhaps we can perform guess and check to factor it. This is x minus 1. This is a trinomial. We're looking for two numbers. When we multiply, we get negative 10, and when we add, we get 3. The fact that the two numbers multiply to get a negative numbers, that means the two numbers have opposite sign, and if we add and get a positive number, then the larger number needs to be positive. 5 and negative 2 would work in this case. X negative 2 and then x plus 5. Make sure we double check it. X times x is x squared. X times 5 is 5x. Negative 2 times x is minus 2x. 5x minus 2x is 3x. Yes, negative 2 times 5 is negative 10. Each of these factors is now linear, so we cannot reduce it further. And so we found the zeros of the polynomial. They are 1, 2, and negative 5. And we also wrote the polynomial in factored form as well.